Hello everyone. In today's lesson, we're going to look at math in science. Math and science actually go hand in hand. Mathematics provides methods for organizing and structuring knowledge. And that knowledge can be something we observe, or that knowledge can be from an experiment we're actually performing. So math allows science concepts and scientific ideas to be grounded by mathematical equations and also tangible numbers. And what it does for us in science is it concretely proves what we or scientists kind of imagine in our minds. It gives it something real and tangible. Even our most famous equation, E equals mc squared, someone actually imagined how to get an atom's nucleus to provide energy. And that's where this equation actually, in its simplest form, really describes how much energy we can acquire from a certain mass. Now, in order to understand how math plays an important role, let's look at some very important words that you've probably learned from elementary school, from middle school, and we see it again in high school. You'll see it again in college if you study science because it's that important to us. It's very central to us in science. And the first word we're going to remind ourselves of is the word variable. When we talk about a variable in science, it really is just an object, an event, an idea, a feeling, a time period, or any other type of category that you're trying to measure. And for our purposes, there are two general types of variables that we use in science all the time. We have an independent variable, and also a dependent variable. Now, just in case you forgot, let's go through formal definitions. When we use the word independent variable, we're really saying it's a variable that stands alone. This variable is also not changed by any other things that we're trying to measure. Thus, independent. And an example of an independent variable happens to be someone's age. Uh, Someone's age is really an independent variable because other factors, such as what they eat or how much TV they're watching, isn't going to change someone's age. So it's not dependent on something. It's something that stands alone. We also need to go over the definition of dependent variable. When we talk about a dependent variable, we're saying it's really a variable whose value depends on other factors. And that example could be a test score. Whoops. A test score can be a dependent variable because it could change depending on certain factors. So it could change depending on how much you studied, or your test score could change depending on how much sleep you got the night before. It could even change depending on how hungry you were when you took the test. So when we talk about a dependent variable, it's something that can vary or can change. Now, from here, in order to understand the role of math in science, what normally would happen is someone would perform an experiment. They want to know something or they observe something. They collect the data and then they organize this information. When they organize this information, it could be in the form of a chart and it can be in the form of a graph as well. So for us right now, we're going to say that we're going to look at the hours watching TV and then the age of someone. So we can kind of, if we had the opportunity to, test a bunch of subjects or children or kids, the age from 6, 8, 10 to even 12, and we can pretend for now that as they get older, you see that the number of hours of TV that they're watching actually is going higher. All right, so from there, what scientists would normally do is, yes, they've collected all this data, They want to organize it in a easy manner for others to read, but they also want to visualize it. And that's where a graph comes along. Now, to remind you of the very important parts of a graph. So the first thing to remember is that we always have the y-axis and the x-axis, and most of you understand that. The y-axis is always going to be our dependent variable. It's the one thing that's going to change. Our x-axis, on the other hand, is going to always be our independent variable. And scientists keep this order of things, what the y-axis equals and the x-axis equals, so we can communicate amongst ourselves. So everyone is not guessing what they mean, that it's always going to be uniform and the same, no matter who makes the graph and no matter who reads the graph. We also include a title, and some of you always forget the title. The title is also written in a very specific manner. The title is always the dependent variable as a function of the independent variable. And some people have some fancy names for the title of their graph, but basically if we just wanted to write a simple title, it's really the dependent variable as a function of the independent variable. So if we kind of think of the experiment or the fake chart that we just made in the last slide, we can say that the actual title of our graph might be graph, and some people actually just write the word graph, of the number of hours watching TV Some people write versus. We can write down as a function of age. So our title has our dependent variable first and has our independent variable afterward. And just to kind of put this together, we know that our dependent variable was the number of hours. So I'm just going to label them for you just to kind of tie it into what we did in the last slide of TV. And our independent variable, just so we remember, happened to be age. If we actually make the graph, this is 6, 8, 10, this is 12, and then we can go 2, 4, 6, 8. When we actually make the graph, we see kind of a shape that looks like this. And when we connect the lines, we don't connect them to the origin because on our chart we didn't start at 0, 0. So we would just create a line that goes from here to here. Right? So this would be that visual representation of the experiment that we created when we collected all that data. Now, from here, what scientists normally want to do is they want to describe the relationship. So people have to know what's actually happening. And they describe the relationship that they visually created in their graph in words. When we describe the relationship, once again, we follow a uniform procedure so other people understand what's happening. And we do that so everyone can communicate effectively. And when we write the relationship in words, it's always the independent variable that goes first. And the reason why the independent variable goes first, even though the title on the graph, it was the dependent, because really the independent variable causes a change in the dependent variable. So we want to know what that change happens to be. So when we look at our last graph or our pretend experiment, we see that we're going to describe really the independent variable first. So we can write down that as someone ages, or as someone's age, let's get my grammar correct, increases, then the number of hours of TV watched increases as well. So what we did here was we stated the independent variable first, which happens to be age, and then tell what would happen to that dependent variable, which is really the number of hours someone watches TV. And this is what they would normally do in words. But scientists then want to change this into symbols. And when we create symbols, then we can actually create an equation, just like E equals mc squared. So when we write the relationship now in symbols, it's still going to be the same way. The independent variable always goes first. And it really goes, the independent variable, and I'm just going to shorthand, is proportional. So they use the symbol proportional to the dependent variable. And I'm just going to write that for you. This little looks like a fish to me, but it's a alpha or proportional symbol in math. Just so you know what it means. Okay, so if we think about our little pretend experiment, then we're saying that age is proportional to the number of hours of TV watched. Now, this is kind of wordy for a scientist, and they want to be able to put this into symbols. So sometimes they make up these symbols, and some symbols are used, so you can't use them again. So I'm just going to say A, which represents my age, is proportional to, let's just use the number symbol, number of hours TV watched. So what I'm doing that for other scientists is I'm trying to create an equation that always links these two variables together. Now, what happens is an equation always has an equal sign. So the proportion is kind of the start. It tells us the relationship. So and this is where math is now involved. I want to somehow get my variables on one side of an equal sign and make it equal to a constant. So watch what happens at this point. They use the magic of algebra and they move these variables around. So if I were to move the number sign over, I would have to divide both sides by the same variable. By doing so, when I have a variable that's the same on the top and the same on the bottom, then that equals 1. So what I currently have right now is the age over the number of hours of TV watched equals, now I can make it equal to the number 1. But the number 1 is not an easy number for everyone. Scientists don't like it. It's not always going to be the number 1. So they realize that and they say, okay, 1, since it's a real number and not a letter or symbol, is actually a constant. So in order to make it more looking like an equation and not just always equal to 1, they're now going to say A equals the age equals the number of hours TV watched equals, the age divided by the number of hours TV watched equals to a constant. And sometimes we can generally use the letter K to represent a constant. We don't use C because that already means Celsius and it can mean heat capacity, but that's what we end up doing. And that's what scientists actually do to create these very complicated equations. They find the relationship and then they see how they can kind of get the relationship to work every single time. And in this case, in this fake experiment, what we're saying is that really age divided by the number of hours TV watch is always equal to some constant. Right? And that's the format that they always use. They can rearrange it using that magic of algebra, but that's the basic idea. And by having that equation there, that grounds that experiment in actual numbers, in true numbers, something that will always get us to a constant. And that's why when people study science, they know that they also need to know math. They go hand in hand all the time When you learn science, you also have to know enough math to get there. And at this stage in your lives, algebra will be enough. But eventually, if you study science in college, then you need to know calculus. Physics is based in calculus. Other thermodynamics and chemistry is based on calculus. So the more science you know, the more math you know as well. Okay, that's it for now. I'll see you in the next lesson.